Hello everybody, this is our video solution to problem 1 from quiz 7. This is fall 2023, Math 307, Linear Algebra at Cal State Fullerton. In this problem, we're given a linear map T from R3 to R2, defined by taking a triple xyz and mapping it to 2x plus 3y and negative 4y plus z. And our goal is to find a basis for the null space of T. So of course, we better know what the null space means. So the null space is all of the pre-images of 0, which for R2 is 0, 0. So the null space of T here would be the set of all x, y, z, all right, in R3. We could write that in R3, such that T of x, y, z is equal to 0, 0. Okay. Now, of course, we actually know what T of x, y, z is equal to. We have it right up above, right? There we go. So I could just replace this here with 2x plus 3y, comma, negative 4y plus z. All right, now I have a pair equal to 0, 0, so I know that each of the individual components has to equal 0. So let's just do a little side work here. We know that 2x rather, no negative, 2x plus 3y has to equal 0. And we also know that negative 4y plus z is equal to 0. Now I immediately see this bottom one I can solve for z, and I'll get z is equal to 4 times y. All right, well now since I've written z in terms of y, I guess I might as well write x in terms of y. So to get x in terms of y, I can solve for 2x. That'll be negative 3y, and then I'll divide by 2. X is going to be negative 3/2 y. So what that means is that if I have such a triple xyz that is in the null space, so it gets mapped to 0, then the x coordinate is actually negative 3/2 times the y coordinate, and the z coordinate has to be 4 times the y coordinate. And so I can rewrite this as a set of all things of the form. Well, let me start by putting a y in the middle. I know that the x is going to be negative 3/2 y, and the z is going to be 4 times y. And now, well, there's no real condition here other than that y has to be, well, a real number. Right? That's it now. So that's going to be my null space. Of course, I wanted a basis for it, so we'll go a little step further. Let's factor a y out of here. So this is y times negative 3/2, 1, and 4. Still, y has to be a real number. And I see this is now just all multiples of this one vector, negative 3/2, 1, and 4. So this is exactly equal to the span of negative 3/2, 1, and 4. Now maybe we don't really like having the fraction in there, so we could clear the denominators, multiply everything by 2, and we get the span of negative 3, 2, and 8. And that feels pretty good. Okay, of course, if you left it at this line right here, this is a perfectly good answer. Okay. I'm going to go through it one other way, only because I think some people will try to do it this way, and that's fine. I think this way we did it is pretty darn quick and not too bad to work with, but a lot of people want to do it with row reduction. So in order to do row reduction, we're going to have to take this map and we're going to convert it into a matrix. So let's see here. Let's maybe go down a little bit. So if I wanted to write the matrix of T in terms of the standard bases, all right. So as my standard basis for R3, I'll just use E1, E2, E3. And for R2, I'm going to call them F1 and F2. But remember, okay, so what does like an E1 mean? This is going to mean 1, 0, 0. And what would an F2 mean? Well, this is going to be 0, 1. All right, so the only reason I switch over to F's is because we have an R3 and an R2, and it might get confusing otherwise. All right, so we want to know what this matrix is. So I'm going to put across the top E1, E2, and E3. And then on the side, we have F1 and F2. All right, well, we got to remember our map. In fact, how about, let's see, 2x plus 3y and negative 4y plus z. So let's just write that. So t of x, y, z is 2x plus 3y and then negative 4y plus z. So if I evaluate this at E1, which is 1, 0, 0, okay, so the x component is a 1, the y and z are zeros, so we would get just a 2 and then a 0. E2 is 0, 1, 0, so I get 3, negative 4. And then E3, that's 0, 0, 1, that just gives me a 0, 1. All right, so I'm going to do some row reduction now. Let's see. How about first I'll divide the top row by 2. So I'm going to scale row 1 by 1/2. So if I do that, I'm going to get 1, 3/2, 0. And then, well, I guess I might as well scale the second row too, right? So let's also scale row 2 by negative 1/4. So then I'm going to get 0, 1, negative 1/4. Okay, and now I guess I can clear this 3/2 if I like. So let's see, to do that we need to multiply the second row by negative 3/2 and then add up. So this is the one where we add a scaled, right? So we're going to add scaled, what is it? We're going to take row 2, multiply it by negative 3/2 and add it to row 1. And so let's see, we'll still have 0, 1, negative 1/4 on the bottom. We'll still have a 1 here. This will now become a 0. What about this piece here? Well, if we multiply a negative 1/4 by negative 3/2, we get 3/8. And then we add that to 0, and we'll just get 3/8. Okay, so this is the reduced row echelon form. And from here, it's very easy now to write down the null space. So because there's only one non-pivot column, right? So we have 3 columns, and the first 2 are pivot columns. So this one is not, so it's only going to give you one vector. So the null of t is going to be the span. Okay, so it'll be one vector. It'll be length 3 here. And so what we do is, because the non-pivot column is the third column, we put a 1 down here in the third position. And then we just take these other 2 pieces, and we're going to put their negations in the top 2 positions. So negative 3/8 and positive 1/4. And, well, okay, maybe we aren't really super happy with denominators. So, okay, we can clear denominators by multiplying by 8. So we'll end up with negative 3, 2, 8. And, hey, wait a second, that actually matches the vector we got doing this the first way. Of course, we've written it vertically instead of horizontally, but that doesn't really matter here. Okay, so we have 2 different methods. Personally, I prefer just doing it a little faster with the first one, but a lot of people are really into doing the whole row reduction thing. So here we go. We have a way of doing that. All right, so I hope this is helpful, and we will see you next time.